Hello, folks. Today is a new lesson on 3.4 extension. So this is an extension to 3.4, and it's called Solving Compound Inequalities. Solving Compound Inequalities. Let's get started. Okay, so this is a considerably longer lesson. I'm going to try to go at a pretty good pace. And there's a few notes in here. A lot of this is going to come pretty quickly to everyone. I do want to let you know that there's going to be 5 examples here, or 6 examples, okay, and no on your own. So take a good solid look at the entire lesson when you have a chance. All right, let's just start out with our I can statement today. Is at the end of the lesson, you should be able to write, solve, and graph compound inequalities. You should also be able to solve and graph absolute value inequalities. So the first part is the definition of a compound inequality. It's an inequality formed by joining 2 inequalities with the word and or the word or. So it's a compound inequality is an inequality formed by joining 2 inequalities with the word and or the word or. Okay, so this is split up into 2 columns here. The left column has solutions of a compound inequality with and. It consists of numbers that are solutions to both inequalities. Okay. So for instance, x is greater than or equal to 2 would be this graph here on the left. X is less than 5 would be this graph here. And if you combine the two, x is greater than or equal to 2 and x is less than 5, you would have these values that are between 2 and 5. That includes the value at 2, but it does not include the value at 5. Okay, so when you have and, you consist of both numbers that are solutions of both inequalities. Okay, so they're part of both inequalities. So if I had a whiteboard here, I could probably show you this on a whiteboard, but we would kind of overlap wherever it overlaps with the word and would be consistent of the numbers that are part of both inequalities. So if you consider this as a solution, the solution to a compound inequality would be those values between 2 and 5, okay, including 2, but not including 5, including 2, but not including 5. On the right here, we have the example of or. Okay, solutions of a compound inequality with or consist of numbers that are solutions of at least one of the inequalities. So the first graph is y is less than or equal to -2. And the second graph is y is greater than 1. So the solution of, if you combine these two with the word or in between, the solution would be the numbers that are have at least one of the inequalities. So they would be at least one of the inequality. Basically, you're going to take the first inequality, and then you're going to show the second inequality on the same graph, and that would be considered an or statement. So y is less than or equal to -2, or y is greater than 1. All right, let's start with example 1 today. Okay, so writing and graphing compound inequalities is the first example. So the question is, write each word sentence as an inequality, graph the inequality. Letter A number x is greater than -8 and less than or equal to 4. Okay, So if you look at this, we are going to first grab my pen here. X is greater than -8, and X is less than or equal to 4. Okay, less than or equal to 4. So basically what we're going to do is, since we have the word and here, we are going to graph all the numbers. Oh, I do have a graph there. Fantastic. Okay. I'm going to graph everything x greater than -8. So I'll first put a circle at -8. Okay, so I'm going to graph everything greater than that. Okay, then I'm going to go over to this. It says x less than or equal to 4. So I'm going to have a solid dot at 4. Okay, and I'm going to go less than or equal to it. So I'm going to go less than. And you can see where they meet. Okay, and where they overlap. And so the graph of this inequality, or the compound inequality, would look like this. So it's everything where they meet, where they overlap. Doesn't include 4. It does include the 4, but it does not include the -8. Letter B, a number y is at most 0 or at least 7. A number y is at most 0 or at least 7. So we have y is less than and equal to 0, or y is greater than or equal to 7. So the way this graph looks, if you go down to the graph here, I might have to move that graph up a little bit just to be a little bit better there. So we're going to graph y is less than or equal to 0. So we're going to put a dot at 0. And we will graph everything less than or equal to 0 like this. So, or y is greater than or equal to 7. So we go to 7. We are going to have greater than equal to dot at 7. And then we're going to head out towards the right because it's greater than or equal to 7. So it's an or part. So we're going to show them both solutions. So basically, if you pick the number 8, 8 is greater than or equal to 7. So with this compound inequality, that would be a solution to the compound inequality. So that would be the first type that you've got going today, is just basically identifying the inequality, the and the or, using these graphs. Some folks will say if it's or, it goes out. If it's and, it comes in. If you want to think of it that way, just be careful when it comes to certain graphs. Okay. All right, let's move on to example 2. So before I do example 2, I just want to note this. You can solve your compound inequalities by solving 2 inequalities separately. When a compound inequality with and is written as a single inequality, you can solve the inequality by performing the same operation on each expression. Okay. So this is second example is solving a compound inequality with a. Okay, so you got this x here, and you've got -3 is less than -2x plus 1, less than or equal to 9. And then we're supposed to graph the solution. So basically we have to solve for x, kind of like with equations, but now we have this big inequality. So you've got a left side here, and you've got a right side, and you can treat them kind of like three parts, the middle part, and then the left side and the right side. Okay, so I'm going to first write the inequality down again. -3 is less than -2x plus 1 less than equal to 9. Okay, so you got to think of it this way. You've got two sides to this. You've got this left side, and then you've got this right side. Okay, as long as we work now, if I don't want to make this look so cumbersome, but if you remember back we learned about equations, we had these railroad tracks where we would separate the left side and the right side. I mean, technically you could have a railroad track right here, okay, and a railroad track right here, all right? And whatever you do to this side of the tracks, you got to do to the middle side of the tracks, and you have to do to the other side of the track, okay? So we could put those in, but it gets to be a little bit cumbersome there, okay? So I'm going to pull that out of there, okay? Pull this out. In essence, you've got these three parts and pieces to it. Okay, so you see the x here. So let's work with this +1, and we're going to try to subtract 1 from the middle. And if I subtract 1 from the middle, I got to subtract 1 from the right side, and I got to subtract 1 from the left side. Okay, with this compound inequality. And this is an and. So basically, the left side and the right side have to be true. So -3 minus 1 is -4, is less than, this is canceled out now, and we have -2x. Should have probably changed my color of my pen there, but that should be fine. Less than or equal to 9 minus 1 is 8. Okay, so you're almost done with this one. What you want to do now is divide by a -2. Okay, now just be careful now when you're dealing with dividing by negatives. You have to remember to flip around the sign. Okay, so if you're going to divide by a -2, all of these signs are going to flip. So this from less than, it becomes greater than. Okay. And this -4 divided by -2 is a +2. Okay. And this becomes an x. And 8, now from less than or equal to, this becomes a greater than or equal to. And you end up with 8 divided by -2, which is a -4. Okay, -4. So there's your compound inequality. Now, when you go to graph this, you've got the left side, x is less than 2. Okay, so we're going to put a circle at 2, and we're going to call that less than. And it also says that x is greater than or equal to -4. So at -4, we're going to have a solid dot. Okay, solid dot, -4. And we're going to, x is greater than or equal to -4. So we're going to go greater than. And where they meet now, where these two meet, we have the solution. Okay. So it's an and. So they have to be solutions to both the left side and the right side. And that would be example 2. -4 less than or equal to x less than 2. Now, you could work with this when you're trying to identify it a little bit better. You could go you could write it as x is greater than or equal to -4, and x is less than 2. And that would be example 2. Example 3, you guessed it, is not an and, but it's an or. Okay, so with example 3 now, you've got or here. Let's do this one quickly. And basically, you've got a left or a right. Okay, so when you go to solve this, you treat them as two separate. Okay, so you write the inequalities out and you basically solve the inequalities, and then we're going to try to graph it. All right, so the first thing I'm going to do is add 5. I'm going to add 5. Then I end up with 3x is less than -8 plus 5 is -3. Then if I divide by 3, I have x is less than -1. And that would be the left side. Now so I'll put my or down here. Or, so now I'll work with the right side, add 1. Add 1, keep working on that solving inverse operations. It's just a big part of this whole entire class and next year too. 5 plus 1 is 6. And if you divide by 2, folks, you end up with x is greater than 3. X is greater than 3. Okay, so your solution would be x less than -1. Okay, so we'll put a circle at -1, and I'll go less than, or x is greater than 3. So I'll put a circle at 3, and I'll put a arrow going out that way. So that would be the solution graph of that compound inequality with the or symbol. And that is pretty much the first part of the lesson. I think what I would like to do is break this lesson up into 2 parts. And I think I will continue on with the absolute value part in the next video. So I'll just cut it off at these first 3 and work on those first, work on those and those or, and then I'll catch up with you on the next video with regards to the absolute value inequalities. Have a great day.